that's so spicy. Oh. It's not helping. Nothing? Oh, no. What makes food spicy? Capsaicin. How does capsaicin affect the flavor of food? YouTube. How does capsaicin affect the flavor of food?
This is Foodies, and today we're going to be talking about the science behind spice. Hi guys, so as we've covered in our previous videos, there are 5 flavors: sweet, bitter, salty, sour, and umami. As you probably noticed, spice isn't on that list. So what is spicy? A family of compounds called capsaicinoids is responsible for the heat of chilies. In this family, there are many different compounds, and they are present in many different types of chilies. The most dominant compound is capsaicin and dihydrocapsaicin. They are basically the same thing, except dihydrocapsaicin also has a carbon-carbon double bond. So now let's just kind of go into the structure. Both of them are vanilloids. That means that they both have a vanillin group, which has an OH, HCHO3, and an R group. And both capsaicin and dihydrocapsaicin also have long hydrocarbon tails, as you can see here. So the hydrocarbon chain that makes up the fatty acids makes the tail end of the molecule hydrophobic or water resistant. So it's insoluble in water. When you guys are drinking milk, casein proteins, which are lipophilic or fat-loving, envelopes the fatty capsaicin molecules, successfully washing them away, thus preventing you from feeling the heat. Non-polar capsaicin is unable to dissolve in the polar water molecules, and instead it spreads all across your mouth when you take a drink of water. So this works by the same principle that causes oil and water to separate. So now that we know about the structure of capsaicin, how does tasting it really work?
Peppers are known to be spicy, but if you know exactly where the heat lies, you can control the level of spiciness your dish has. The heat comes primarily from the placenta. The seeds have some heat, but not as much, and the flesh of the pepper has even less. The seeds are spicier than the flesh because the seeds are embedded in the placenta. They are more in contact with the placenta than the flesh is, and are therefore more in contact with the high amounts of capsaicin in the placenta. Once you bite into one of these guys, well, then what happens? Well, if the pepper is really spicy, your nose starts running, your eyes start to tear up, and most importantly, your tongue feels like it's burning. Now let me explain how this works. First, here's a little background knowledge. We have polymodal nociceptors all over our body. The word nociceptor refers to pain receptors, while the word polymodal means that the receptors respond to many different forms of sensory stimulation, such as heat, touch, or chemicals. These receptors are basically the nerve endings of certain neurons. On the polymodal nociceptors are proteins called TRPV1 and ion channels. They can sense and detect damage. It can be activated by heat, capsaicin, and acid.
So what does this have anything to do with why your mouth is on fire? Well, the molecule called capsaicin is responsible for the fiery sensation in your mouth. As we mentioned earlier, capsaicin is a vanilloid because it has a vanillin group on it. Because of this, the capsaicin can bind onto the TRPV1 protein. Initially, the ion channel is closed. Once the capsaicin binds onto the TRPV1 ion channel, it opens up and allows for calcium and sodium ions to go through. This allows a message to be sent to your brain that tells you your mouth is burning, even if it's actually not. As a response, your body tries to cool itself off, so you start to sweat and your eyes and nose start to run. This is your body's way of trying to remove the threat. But there are some benefits to eating spicy. In response to pain, your body releases endorphins and dopamine. Combined, these can create a euphoria similar to a runner's high. But the amount of spicy food you should eat depends on your tolerance for spice. We don't know for sure what allows for some people to take more heat than others, but there are many probable factors. Some people are born with less sensitivity to spice. Certain versions of TRPV1 can be more or less responsive depending on the individual. Some people may experience a desensitization effect. It is when people who eat a lot of capsaicin need to eat even more to taste the same level of spiciness, to feel the same burn. Another explanation is that it's not the food that burns less for some people, but that some people just like the burn because of repeated exposure.
While spicy isn't a flavor, we process it in a similar way to how we process sour and salty foods that we talked about in our prior video. The tastins interact with proteins called ion channels that are located on the surface of our taste cells. The tastins increase the concentration of anions, positive ions, in the taste cell. This results in messages being sent to the brain about what we are tasting. This process is similar to a lock and a key. For processing both flavor and heat, ion channels or proteins are the lock, while the sour or salty tastin, or the capsaicin molecule, act as the key. This all occurs in order to send a message to the brain to feel and react a certain way, whether it's flavor or pain. There has been some speculation that spicy food and capsaicin may increase salt sensitivity, but there is still ongoing research on that topic. Although capsaicin doesn't affect flavor, the flavors within a pepper can enhance the experience of a dish dramatically.
Please don't forget to like and subscribe to see more videos like these. So the salsa has been made, and there are two versions of it, a spicy one and a not so spicy one. This is the spicy one because it has the pith of the jalapeno and the seeds of it too. My brother wanted to taste my salsa, and depending on whether it's spicy enough or not, he's also going to try this pepper. And then we're going to test to see if drinking milk and potentially even butter can help relieve his pain quickly. So now he's just gonna take like a bite of the salsa. Is it spicy?
A little bit.
You need to chew a lot.
Never mind.
You need to chew a lot. Because it has the pith in it, and the pith is the spiciest part of the pepper, and it has a lot. See? His eyes are watering. His face is getting kind of red. Are you done? Do you need any milk or butter?
A little milk.
Okay, a little milk. Do you want to move on to the pepper?
Sure.
Okay. So now we're going to move on to the pepper. So take as big as a bite you want. Okay, just go for it. Okay, chew it and then we'll see what happens. Is it spicy?
Yes.
Is it spicier than the salsa?
Yeah.
By a lot or by a little?
Right now, never mind a lot.
Okay.
I need milk.
Is it getting better? Tiny bit, but now it's back, right? Do you want to take another bite? See, now he's breathing hard. how does it feel after the milk? Is it still spicy in your mouth?
Doesn't make a difference.
All right. So now can you try the butter? 2. And you can even like gurgle with it if you want to. Is that helping?
Oh.
A lot or a little?
It helps a lot.
I don't know. Do you need any more butter? Wow, it's already done and you already just like ate half a pepper? Okay. But you don't have any more spiciness in your mouth?
I have a little bit, but it's not bothering me that much.
After you had the milk, how bad was it?
The same.
Like whether you took the milk or not?
Mm-hmm.
Okay. Thank you so much for tasting everything.
Here, you can try it.
Okay.